Okay, so I'll be explaining the simple slope-intercept form. So, at first this may seem complicated, but it's actually really easy. So, the slope-intercept form, we can start off with the equation, is y is equal to mx plus b. Okay, now what this basically represents is a line. It's the formula for a linear or just a straight line in simple terms. Okay, and you might be wondering what m and b means, right? And I'll explain it to you. So let me just first let's sketch out a simple graph like this. Okay, so your y-axis is here. That's your y-axis. X-axis is here, and then okay. So we got an arbitrary or just a line to represent. So that's our line right there. Okay, so then when graphing a line, there are two distinct characteristics you must remember. So one is where the line intersects the y-axis. And the reason why you want to do this is because again, it's a very easy to identify point on the graph that you can always use, right? And it's in the equation. So like in our representation right here, our line is directly intersecting 0, 0, okay? So 0, 0, the origin, right? And then in an equation, the y-intercept is b. So that's that right there is the y-intercept. Okay? And remember, the y-intercept is where the line intersects the y-axis. Okay. And then the slope is a little bit more interesting. So when you think of a slope, like most people, or how I like to think of it, is like a hill. So like a little hill, right? So then the slope will be how steep that little, I guess, blue hill is, So how steep it is, that's basically what it means for a line, right? So how steep the line is. So then, but then what we mean by that and what we mathematically, or how we would, mathematically represent it instead of a blue hill, it would be more like, it would be more how the change, so it would be more like how the y changes. So as the x changes, how does the y change, right? So then, like the basic form would be the change over y over the change over x. And I bet you heard this somewhere in the class or whatever, but then yes, the change over y, change over x, and the triangle just represents the change. Don't need to worry about that. But then yeah, so it's just basically how steep the line is. Okay, and then in the equation, m represents the slope. Now you might be wondering, how do we get slope and y-intercept, right? And usually we when we're trying to figure out the equation for a line, we like to find the slope, because once you have the slope, you can, and at least a point on the line, you can get the y-intercept. Okay, so to find the slope, like I said, is the change over y or the change of x. But what does that really mean? Well, if we can rewrite it as y2 minus y1 over x2 minus x1. Okay, that's what you would show it as, and then now you might be wondering what y2 and y1. It just means, so then you have two different points. So then that's why you have two different x values and two different y values. Okay, let me get an example so we can visually see and actually maybe practice trying to get the slope. Okay, so then let me just redraw a graph right here. Just a simple graph. Okay, remember to always label your axes or your axes, because it'll be very important, because in the future the axes of the graph can be different. Okay, so then you go 1, 2, 3, 4, 5, 1, 2, so on, and then 1, 2, 3, 4, 5, and then we don't really need to draw the negative right now because we just want to focus on this area, okay, the top half. Okay, so let's draw a line. Start from here. over here, we go up here. Okay, now that's our line. Okay, and then we can pick out a few points. So then when you're trying to look for points on the line, the best thing to do is find the point that are well, I wouldn't say like they're called like perfect points, like the ones that line up exactly right or close usually. So we already got 1 point, 0, 2, which is also the y-intercept, but we can just use it that too. That's another neat trick about it. Okay, and then we can use this point. It's very close to the line, but because I'm very bad at drawing, it's not direct line, but yes. Okay, so 1, 3. Okay, that's our 2 coordinates, and then now what we can do, remember the equation for above, y2 minus y1 over x2 minus x1, right? Well, we can label our coordinates, right? So then this will be this, I guess doing like a different color. This will be x1, that'll be y1, that'll be x2, that'll be y2, okay? Now it's fairly simple, right? You just plug it in. So then y2 would be 3, y1 would be 2, x2 would be 1, and then x1 would be 0. And usually with slope-intercept form, it doesn't really matter what is x2 and what's x1, but what does matter is that the change of y is always up, is always being divided by the change of x, so it's always on the top or the numerator, right? Because if you don't do that correctly, you get a totally different slope, which can mess up everything. Okay, so then we do 3 minus 2, which is 1, 1 minus 0, so it would be also 1, and then we can just simplify this out to 1. So nice. Now we got the slope. So the slope is equal to 1. Equal to 1. Okay, now we just go back to our slope-intercept form. If you remember, it's y equal to my mx plus b. Okay, and now we just plug in m. So y is equal to 1x plus b. And if you look back at our graph earlier, like I said, we already found the y-intercept 0, 2, right? And also another trick to easily find the y-intercept is that is just look for a point that with the x value of 0, they can always know that's the y-intercept. This is especially important when you're dealing with not a graph but only with data values. And we'll do that in the future, but this is just to give you a general idea, okay? So we know our y-intercept is 2, so we just plug it in, and we got y is equal to 1x, or we can just simplify that to x, because 1 times anything is equal to itself, so y is equal to 1x plus 2. There you go. You just learn how to do the slope-intercept form, and I'll give you one more example, just in case. This time, though, will be a little bit different. You still have the same general idea, but it's a little bit more testing your skills. Right? Okay, so 1, 2, 3, 4, 5. Okay, so draw the line here. Somewhere a line. Yep. Okay. So now you might be wondering, look, if you look at this line compared to the one we just did, you can notice the difference, right? Instead of the line going up, it's going down, right? And when it's going down, we usually call it a negative slope. So this is a negative slope, and this one over here, the top one we just did, is a positive slope. And what it basically means is that the slope will be a positive number, right? And then this downward going slope will be a negative number, so it's still being negative. Okay, so then when you see these graphs, always remember the slope is negative. Okay, but everything's basically the same, so it shouldn't be that bad. So we already got, like I said, 1 point on the line, 0, 5, or the y-intercept, and just pick out this point right here. So that is 1, 4. Okay, and now we just label these like we did above. So we got x1, y1, x2, y2, and then plug it in. So, 4 minus 5 over 1 minus 0, okay? So, now, you just solve it. So, we got negative 1 over 1, or a slope of negative 1. See? And we know that we did this correctly because is negative, and the line that we showed is going down, so negative, right? Negative line. Okay, and now we already know the y-intercept is 5. We just identified it earlier, so it'll be y is equal to negative 1x plus 5, or y is equal to negative x plus 5, and that's it. Okay, so slope-intercept form, not that bad. And in the future, you will be handling in different ways and in different forms, right? So then, like, I already showed you the equation. So here, the equation, so the slope-intercept form right here. And also, I also showed you the graph, right? Because I'm drawing the graph, okay? But in the future, there will be one more. So there's one more to represent as a data table. Those can be a little bit more tricky at times, but once you know what you're doing, it shouldn't be too bad. Okay? Have a great day. See you in the next video.